All right, we have a squirrel. And by the way, this is a rate in, rate out problem without your calculator. So we have optimization to do, which, by the way, we're going to do in part A this time. So it'll probably take me all of this white space to do. So basically, the squirrel starts at building A and travels along a straight wire to building B. You can envision this, can't you? He's got time 0 to 18. And I'm not even sure it tells us the units. Reading again to see if there are units. I don't see units, which is fine. Okay, so they want to know... Oh, the optimization is not the first problem. Ha, it's the second part. So, in the first part, we just want to know where the squirrel changes direction. And the squirrel is going to change direction at time 9 and 15 because the velocity curve, v of t, crosses the x-axis. And you need to write that. You can't just leave it as touches the x-axis. It can't just be a 0 of the velocity function. You need to indicate that velocity changes sign. And you don't have to specifically say from negative to positive or positive to negative, just that velocity changes sign. Okay, part B is our big optimization problem. So at what time on the interval is the squirrel the farthest from building A? So we have to draw our little table of values, and then we'll label this the distance from building A, and we know we need 0 and 18, our two endpoints. And then we already identified in part A the two zeros of the velocity function, so 9 and 15. So we're told that at time equals 0, this squirrel is at building A. It starts at building A, so this distance is 0. Makes our life a little bit easier, frankly. So then we need to integrate this velocity function on the interval from 0 to 9, on the interval from 0 to 15, and on the interval from 0 to 18. So let's get going. For 0 to 9, we just need the area of this trapezoid. So the area of a trapezoid is 1/2 times the height, which is 20, times base 1, which is 9, plus base 2, which is 5. So that integral is 10 times 14, which is 140, whatever the units are. So next, we are integrating 0 to 15, which is going to be the original 140 plus a negative area, negatively signed area of this trapezoid that lies underneath the x-axis. So that area is 1/2 times 10 times, let's see, 15 minus 9 is 6, plus 14 minus 10 is 4. So I end up with 1/2 times 10 is 5, times 10 is 50, so 140 minus 50 is 90. So then, for the integral from 0 to 18, I take that 90 and I'm going to add to it this section right here, which is another trapezoid with, that means I have 1/2 times the height, which is 10, and then base 1 goes from 15 to 17, that's 3, and base 2 goes, did I say 15 to 17? I meant 15 to 18, which is 3, and then base 2 goes from 16 to 18, which is 2. So I have 90 plus 5 times 5, or 115. So at what time is the squirrel the farthest from the building? Well, that time is going to be time equals 9, and the squirrel is 140 whatevers away from the building. So let's copy this problem onto our next page and do parts C and D. Find the total distance the squirrel traveled on the interval from 0 to 18. Well, on my prior work, I found out that the area of this trapezoid is 140. I found out that the area of this trapezoid is 50, and I found out that the area of this trapezoid is 25. So the total distance traveled is the summation of all of those areas. We don't sign them as positive or negative because even though the squirrel is going back towards building A on this interval, he's still traveling a distance. So 140 plus 50 plus 25 is 215. And then part D, we'll finish the problem with part D. Write the expressions for the squirrel's acceleration, velocity, and distance that are valid just on the interval from 7 to 10. So I'm going to start with velocity because the velocity curve is this linear function right here. So velocity equals, and what I have is a slope of, on the interval, let's just do the average rate of change. So change in y values, negative 10 minus 20 over change in x values, 10 minus 7. So negative 30 over 3 is negative 10. That is the slope. And then pick either value to use, pick either endpoint of that segment to use to create your point slope form. Now, I know we typically tell you not to multiply out point slope form, but I'm going to multiply it out anyway so it's easier to differentiate. So negative 10x plus 70 plus 20. So that is my velocity function, is negative 10. Oops, I just realized I'm using t's and x's. So why don't I fix that and I'll just use t's as our time here. So now for acceleration, we just have to differentiate velocity and we just get out negative 10. So that is our velocity function. And then to get the position function or the distance function, we have to integrate the velocity function. So the position function that they want us to call x of t is going to be the integral of this velocity function. So negative 5t squared plus 90t plus c. And the question is, what is the initial value? And to get that initial value, I need to find the area of this trapezoid, cutting it off at 7. So it's not that 140. It's going to be, the c value is going to be 1/2 times the height of the trapezoid times base 1 plus base 2. So 10 times 12 is 120. So my position function is negative 5t squared plus 90t plus 120.